Greetings, seekers of knowledge. Have you ever found yourself gazing at the sky on a clear night for a long time? Profound questions have probably popped into your head, such as, are we alone in the universe? How many stars and galaxies are out there? Is the universe finite or infinite? Did I swallow a chicken bone at dinner? Will I die? But if you're even more curious, you might have asked yourself other questions like, what's below the solar system? This question, although seemingly simple, leads us to explore fascinating concepts about the structure of the universe and our position within it. To begin delving into this topic, we must clarify one fundamental thing. We can't say that the solar system and other systems, or galaxies, have an up or down in the conventional sense. So from there, we start to question our usual perceptions. It's true that celestial bodies have axes of rotation, like Earth. From a certain point of view, you could say that one of the poles of that axis is up and the other is down. But in the vast stage of the cosmos, these distinctions lose meaning. Space has no preference for any particular direction. To illustrate this point, let's think about the astronauts on the International Space Station. For them, up is their head and down is their feet. But this makes no sense when the person floating next to you is floating upside down. In space, the concepts of up and down are only conceived with respect to gravity. Down is simply the direction toward which the nearest significant mass pulls. Now, if we set aside these considerations for a moment and focus on how the solar system is arranged within the galaxy, we encounter some surprises. Many people have in mind the classic image of the solar system, an orderly and symmetrical plane where planets orbit around the sun in almost perfectly circular orbits. This representation gives the impression that the solar system is horizontally arranged in the Milky Way, like a disk floating in a cosmic sea. However, reality is much more dynamic and complex. The solar system isn't as neat, static, and perfect as it appears in those simplified representations. For starters, we know that the Milky Way, our home galaxy, doesn't stay still. It constantly rotates, and its majestic spiral arms move through space in a cosmic ballet that lasts millions of years. Our solar system, as an integral part of this galaxy, participates in this grand movement. It travels at an astounding average speed of 514,000 miles per hour around the galactic center. To put this in perspective, that's more than 143 miles per second, or approximately 1,000 times faster than a commercial airplane. This dizzying speed leads us to complete one orbit around the center of the Milky Way every 250 million years or so. This period is known as a galactic year. Think about this: since dinosaurs dominated the Earth until our days, our solar system has completed less than one turn around the galactic center. But the solar system's movement isn't limited to this galactic orbit. The planets revolve around the sun more or less as seen in traditional representations, but at the same time, they're moving with the galaxy. Imagine a three-dimensional spiral where each planet traces its own unique path through space, while the whole set moves as a block. This complexity of movements has been the subject of fascinating studies and visualizations. There are animations that attempt to capture this cosmic dance, showing how Earth and other planets move along with the sun on its journey through the galaxy. These representations have gained popularity on social media, captivating the imagination of millions of people. However, as often happens in science, these visualizations aren't without debate. Some of the first animations that became popular caused a stir among astronomers because they weren't entirely accurate. It's not that they were completely wrong, but some details gave an imprecise idea of the real movement of celestial bodies. For example, some animations showed the sun as if it were at the head of all the planets in its movement through the galaxy. If this were true, it would imply that the sun is above the plane of the ecliptic, the plane in which most planets orbit. In reality, it's some planets that aren't exactly in this plane, while the sun remains more or less in the center. These discrepancies led to the creation of more accurate new animations, offering a more correct interpretation of the movement of the planets and the sun on their galactic journey. These improved representations help us better understand the true nature of our cosmic neighborhood. One of the most surprising aspects of the solar system's arrangement in the galaxy is its tilt. The solar system as a whole has an inclination of approximately 63 degrees with respect to the plane of the Milky Way. To visualize this, think about the slope of a car's windshield. It's a considerable angle that challenges our intuition about how the solar system should be oriented. This inclination has fascinating implications. It means that on our journey around the galactic center, we oscillate up and down with respect to the plane of the Milky Way. At times, we find ourselves above the galactic disk, at others below it, and at others passing through it. How do we know that the solar system is tilted like this? The evidence comes from careful observations of the night sky. There are panoramic images of the sky that reveal two distinct bands of light. The most prominent is the famous band of the Milky Way, that bright strip we can see on dark, clear nights. But there's another band of light, fainter, running in a different direction. This second band is known as the zodiacal light. It's caused by sunlight reflecting off small particles of dust and rock that inhabit the plane of the solar system, mainly between the Sun and Jupiter. The inclination between these two bands of light gives us the key to the orientation of the solar system with respect to the galaxy. These observations can also be corroborated in the infrared spectrum, where the structure of the galaxy and the position of the solar system become even more evident. In these images, the Milky Way appears as a bright band of light, while the plane of the solar system can be identified as a separate structure, inclined with respect to the galaxy. All of this leads us to reconsider what up and down really mean when we talk about the solar system. What we thought was down according to the axis of rotation of the solar system turns out to be in a completely different direction when we consider its position in the galaxy. It's a reminder of how relative these concepts are on the cosmic scale. To help visualize this, there are interactive tools that allow you to explore the position of the solar system in the Milky Way. These tools usually show the solar system as a static plane to simplify things, but they allow you to zoom out to see nearby stars and then move even further away to appreciate our position in the galaxy. It's when using these tools that you really start to understand the vastness of the cosmos. We see that we're surrounded by countless stars, many of which probably have their own planetary systems. Beyond that, the spiral arms of the Milky Way extend and even further beyond other galaxies in the observable universe. This perspective reminds us how small we are on the cosmic scale. Our planet, our solar system, even our galaxy, are just tiny dots in the immensity of the universe. And yet, it's from this small corner of the cosmos that we've been able to discover and understand so much about the nature of the universe. Before concluding, it's worth reflecting on a fascinating detail, the zodiacal light we mentioned earlier. Why is it called that? The term zodiacal refers to the zodiac, the band of constellations through which the sun appears to move throughout the year from our perspective on Earth. The zodiacal light is most visible in this region of the sky because it's where most of the dust in our solar system is concentrated. This phenomenon, although subtle, is a constant reminder of the structure of our solar system and its relationship with the galaxy that surrounds us. It's a bridge between what we can see with the naked eye and the vast cosmic systems of which we're a part. In conclusion, the question, what's below the solar system, has taken us on a fascinating journey through the structure of the cosmos. We've discovered that the concepts of up and down lose meaning on the galactic scale, that our solar system is tilted and in constant motion within the Milky Way, and that our position in the universe is both humble and amazing. The universe is full of fascinating mysteries waiting to be discovered. Each answer we find usually opens the door to new questions, keeping our curiosity alive and our desire to explore and understand the cosmos. So the next time you look at the night sky, remember, you're seeing not just stars and planets, but also the grand movement of cosmic systems of which you're a part.